the IMBeR OSC Organising Committee for the opportunity to talk to you today on this subject, and particularly to give a perspective on sort of integration of natural and human dimensions of the social sciences from a natural scientist perspective. So my background is in the natural sciences, although my work has always had an interdisciplinary slant, but I by no means claim expertise in this area, and we defer to many of the people in this room who are true social scientists to represent much better some of the work I'm going to talk about today. But there is a great necessity, we would argue, for the interdisciplinary work between natural and social scientists. I selected a somewhat provocative title, Dead Ends and Grasping Hands. So what do we mean by that? The idea is that we've already, in many fishery situations, we're already going down a one-way route. And if we're not careful, we'll end up at a dead end in the sense it's very difficult to turn back. And the reason for that is basically, writ large human greed and human need. And those are the grasping hands, so there's some symbology there. And that's largely due to what I would argue is failed governance. And that argues for the need to do what we're doing better. Oh no, hold on. What am I pointing this at? Okay. Bernard, I need your help for someone's. It needs to be turned on, thank you. So I'm going to talk a lot about fisheries because that's my background, but I think this whole concept of these ecosystem services is a useful one, at least in terms of what it represents, if not in terms of the language used. It allows us to think more broadly about the uses and benefits that we as humans gain from the oceans. Fisheries are important, but it's not just fisheries. And I'm sure most of you are familiar with this, and we've got the way this has been outlined as part of the millennial assessment. And so there are basically 4 services: supporting, provisioning, regulating, and cultural. But what I like about this diagram is that it shows quite clearly how these are linked to human well-being. And it's important to recognise these linkages throughout our discussions this week and throughout what I'm going to discuss with you this morning. And just last thing on this is that Leslie and McLeod a few years ago looked at how this services concept actually applies to coastal and marine systems. And what they've done here is ranked it from red, meaning that they're very important, to white, meaning not important, and grey means not evaluated or not ranked. And so the critical thing here is that the red areas, there are quite a few, but they're largely related to fisheries. So food for humans, fish for animals, biodiversity and employment. These are all related to fisheries issues, which argues or substantiate that, I guess, in part why I'm focusing on fisheries in part through this talk, but also to outline the other areas of services that oceans provide. So I'd like us to keep this big picture in mind as we walk through some of this. So we have lots and lots of evidence, lots of papers written, lots of careers made on the fact that we've got collapsed fisheries. Why? And so this is why we come to this argument about failed governance. Now, what do we mean by governance? This is one of these terms that's becoming increasingly used in the last decade or so, and apparently there are lots of definitions. So my good friend Ratana here provided me with this particular definition, which is, I think, a useful one. So governance refers to mechanisms, processes, and institutions through which public and private sectors articulate their interests, exercise their rights, meet their obligations, and mediate differences in order to make decisions affecting society. So basically governance permeates across the scale, if you like, from large-scale institutional governance to much smaller informal governance. And again, it's important to remember that range when we're talking about how governance fails. So we can point to many different aspects of why fisheries have failed, why governance of fisheries have failed. Again, it's a business, it's driven by profit. And so in many cases, it's not looking at the sustainability of the systems. And there's often a mismatch between governance users and resources. We've got top-down management, global markets driving things, competing interests, etc., etc. There's also, maybe our science hasn't always been as good as it should be. We've been living on a single species model for a long time. There's now an ecosystem approach, but in many realms it's still largely single species. And maybe selective fishing is not the right model. And an FAO group 12 years ago came up with a set of conclusions of factors for unsustainability and overexploitation. So we've known about this for a long, long time. And it all points to the fact that we need to do something more, and now we're faced with the challenges of global climate change. And again, we've talked quite a lot about that during this meeting. And again, more clears have been made on how do we address the challenges of climate change from a fisheries perspective, but more broadly than that too. So one of the things that I want to chat about with you this morning then is ways forward for IMBeR in the face of resource management, of global environmental change, and the fact that we need to help promote the science from both the natural and social sciences perspective that enable us to do this better. And it's not just in the natural sciences that we're recognizing that we need to have bring in the social sciences. There was a recent report from the International Social Science Council which argues that social science needs to be at the heart of understanding and responding to global challenges, such as climate change, pollution, resource limits, etc. And this report was in part arguing, making this case to social scientists. So it's not just that natural scientists are saying, hey, we need to bring in more social scientists into what we do. Social scientists are also becoming increasingly aware that their expertise is required to address these global problems. So how do you do that? We've been talking in several of the sessions this week already about different approaches that are being used, and I'm not going to go into all these detailed approaches. What I just want to do here is make a dichotomy. Too often we start research projects from a natural science perspective, and we're quite good now in the natural sciences taking interdisciplinary views, so we're incorporating oceanography and ecology and biochemistry and stuff, and we can make a project that looks quite good. And then either because it's good for getting funding grants or it's an afterthought, but generally the social sciences are often like the icing on the cake, and sometimes the cherry on the top too. So it makes it look more appealing. So this is one of the approaches that we often see, the sort of icing on the cake. The argument is that this is not sufficient. A more successful approach will be where the natural and social sciences are integral to the design of the project. And I think Quéré made this point yesterday, that not only are you likely to get a better product at the end of the day, the natural and social sciences will also learn from each other. It's a win-win. And this is more of a tiramisu approach. So a tiramisu, most of you will know, is kind of like a layered cake. Everything is integral to its design, and the product is so delicious. So I'll make this differentiation throughout the talk. So we've used the term of human-ocean interaction, and basically what we mean by this is a systems thinking approach. And there are lots of examples of this. There's different terminology: social ecological systems, human environment systems, coupled human and natural systems. There may be nuances in terms of the different names, but essentially what it means is a systems thinking approach. And this is a classic diagram from Elinor Ostrom, which essentially outlines the core subsystems in the framework. So you've got, your resource system here, your governance system, your users, and your resource units. You've got interactions between them and outcomes. So this is the basic idea, right? We're incorporating the social and ecological systems. The diagram I prefer, and this is from a new study group that's part of ICES, which is led by Manuel de Lorenzo, looking here at coastal hypoxia, and clearly articulating that it's actually three systems: the environmental system in blue here, your marine ecosystem, and your social system. And this is kind of like a spaghetti diagram that shows you that it's a little bit more complex, that there are lots of linkages and interactions between different components of these three systems. And it's important to understand how they're linked together And you know, what aspects of these different subsystems have more influence than others, if you like? Where are the kind of trigger points? In the social systems, what are the key drivers? Who holds power? What forces the situation? Why are people? What are the human drivers that are causing the coastal hypoxia? So this is the kind of framework we want to work within. So now I come to IMBeR, and what I want to do in this part of the talk, hopefully what I've done is outline to you why it's important to take a sort of integrated approach. Is to look at what IMBeR's been doing, and then the last part of the talk, I'll talk a little bit about where we might go. You've seen this before. This is our sort of standard IMBeR presentation. There are 4 research themes, so we're addressing the 4th one, the responsible society. But there's one thing I want to point out to this diagram, is there's something missing from it. I wonder if anyone can see what it is. Thank you, Lisa. Where are the humans? So we have this, I mean, this span has been around now for 10 years. Responsible society has been part of IMBeR since its onset. It's always been the 4th dimension, and it's only in the last 5 years that we've had a human dimensions working group looking at this explicitly. And I think if this theme is seriously part of IMBeR, then our symbology has to represent that. Otherwise, people looking at this will have no idea that humans are part of the equation. So it's a slight aside, but I think in terms of where we go next, we need to revisit our presentation of ourselves. All right, moving on. So this is theme 4, to promote an understanding of the multiple feedbacks between human and ocean systems, and to clarify what human institutions can do either to mitigate anthropogenic perturbations of the ocean system or to adapt to such changes. And here again we have a little diagram explaining that. I want to first talk about what's been done in the regional programs under IMBeR, and then I'll talk a bit about the work we've been doing in the Human Dimensions Working Group. As you know, there are 4 regional programs: CLIATOP, ICE, ESSAS, and CYBER. And thanks to Olivier for some of these slides. So climate impacts on oceanic top predators. As Eileen mentioned the other day, this was a project originally started under Globek. So CLIATOP uses a worldwide comparative approach to understand the impact of climate variability in fisheries on open ocean pelagic ecosystems, the top predator species, and support ocean ecosystem governance. So that's quite a clear articulation of the problem, and we've got a human dimensions represented in that overall aim. The structure of CLIATOP has always been to include a socioeconomic working group as part of its to address this goal. And this working group has essentially 4 overarching questions. How can effective governance be achieved? What do we need to understand about the human dimensions of the ecosystem? What type of information is needed from the science community? And how can research contributions from social and biophysical research be more effectively integrated to serve those information needs? These are 4 very good key questions. And what's interesting to point out about this is that they have a clear problem. So governance of oceanic fisheries and sustainability of marine top predators. So it's easier to formulate good, clear questions when you have a good, clear challenge. They've got 3 focal areas to address these questions, and I want to focus on number 3 just briefly: development of future scenarios. And Olivier presented this earlier this week. But what they're doing here, and this is a group, this is a product of the work from the working group 4, which is the modeling group, and working group 5, which is the socioeconomic group. And what they're doing here is developing scenarios together with stakeholders, the regional fisheries management organizations, industry, to look at possible futures. And they're using the, in green here, these are their system models, and red are their bioeconomic models coupled to markets. They've got global, they've got global drivers which are driven by IPCC shared socioeconomic pathway models. But the idea of this is to develop these scenarios with industry, with our FMOs, to explore possible options. And I invite any of you interested in this to chat with Olivier more about this, or ask him questions afterwards, because I haven't been involved in this. And then the other nice work that's coming out of the CATEGORICAL group, recently published a paper in COSAS arguing for a new science policy partnership for the governance of oceanic predator species. Currently, top predators are managed through regional fisheries management organisations, and they're arguing for some sort of umbrella group, a partnership for the sustainability of ocean ecosystem services, which is the thing in blue here, which would be associated, RFMOs and other kind of fisheries organisations, etc., NGOs, will all be part of this group. And there'll be links with the sort of bigger global groups like CITES, CBD, etc. And this would, in parallel, there would be an international scientific programme which would provide the science advice. And that, again, would have connections with sort of global scientific groups. So all this to say that there's some really nice work going on in CATEGORICAL. It's kind of at the macroeconomic level, if you like, but it's an example of what can be done. And I'm giving it the Tiramisu stand, because really from the outset they've had the socioeconomic components as part of the project, and they're working this through, addressing their key questions. Another regional program is ICE, Integrating Climate and Ecosystem Dynamics in the Southern Ocean. And this is, ICE coordinates circumpolar research, basically to understand climate interactions, ecosystem dynamics in the context of sustainable management plans. So here again we've got this idea of management. And CAMLAR, the Convention for the Conservation of Aquatic Marine Living Resources, is a management body for that area, and it takes a precautionary ecosystem-based approach. There are two main fisheries, toothfish and Arctic krill. And ICE has done lots of, biogeochemicals, food-led modeling research, oceanic observation, etc. But where it comes into working in the human dimensions realm is a more recent development, looking at working with CAMLAR. So in the Antarctic region, there isn't a large, there's no indigenous population, of course, but there are a wide range of global stakeholders, and Eugene has identified fishing, tourism, nutraceuticals, bioprospecting, etc. And there needs to be a dialogue between scientists and the above sectors in order to get effective ecosystem management. And they've, ICE is committed to improving work in this area, and they recently, in fact earlier this month, had a stakeholder engagement event to work in this area. I don't think that report is out yet, but again, I invite you to, what? Talk with Eugene about that. Okay. They get a cupcake with icing on top. ESSAS is the ecosystem study of the subarctic seas. And again, the research to quantify and predict impact of climate change and marine ecosystem sustainability. There is, again, a human dimensions working group there, but that's had little success in really getting off the ground yet. And this is one of the challenges, and this comes to the icing on the cupcake kind of approach. ESSAS, as all the regional programs, are largely sort of done from a science perspective, and we need more social scientists to be part of that. So this is still work in progress, and that's a cupcake. I'm moving a bit more quickly now because I've been told I've only got a few minutes left, and I've hardly done. Cyber is in the Indian Ocean, and the goal of cyber is to improve our understanding of the biogeochemical cycles, interactions between the cycles and marine ecosystem dynamics. So again, a very science-based project, and then linking to how that science might be used by policymakers. And an example is looking at, for example, the variability of sardine catch with trends in chlorophyll. Again, this gets the icing on the cake stamp. All right, I want to move quickly on to the Human Dimensions Working Group, and I'm shortchanging us here. So we've been in existence for 4 years now, and we've been essentially focusing in 2 areas. One is in trying to build community, disseminating information, and building ideas. And so we've done that through both having a special volume of COSAS, which was a kind of product in part from our first working group meeting, and then hosting various meetings, international meetings, and this is part of building community. But the other important area, what we feel is an important area, is we've been developing what we call a decision support framework called IMBeR Adapt. And it's a tool that's basically using, based on information that already exists. It's knowledge learned from past experiences of responses to global change. And the idea is to develop a tool that will enable decision makers to rapidly assess what might be the best response to the challenge that they're faced with. It relies on contextualized place-based case studies, and it's essentially global in reach. But it's not a simplified global approach. We try to still maintain the differences in different case studies, the peculiarities of each particular situation. We need this kind of approach because, as you know, global change is happening now. We need to adapt to it. Importantly, we need to identify the most appropriate response, and that's often difficult to do. Often in local communities, climate change is just one of several challenges. Putting food on the table may be more important. But I want to underscore the fact that there's a lack of a coherent framework out there to allow decision makers, users, stakeholders to identify what kind of strategies have worked in different situations under under different conditions, and that's what we're trying to put together here. We take a systems-based approach to this, so we've talked about this already in the presentation, building on the DIPSR framework, an interactive governance framework, and we've developed a questionnaire with a sort of description of what the issues are in each of the contextualized-based case studies. So first of all, what's the issue? What's going on? What's the challenge? And then we go through quite a detailed description of that, looking at the state of the system, the stressors, the change in the system, the impact, and importantly the responses. What was the response? What were the objectives of the response? What we add, this has been done elsewhere, there are case studies out there of course. What we're, I think, bringing to this, the value added, is an appraisal of those responses then. So we've identified in the responses what their objective were, and then we're asking where the objectives of the response achieved, were the outcomes achieved. So this enables users, decision makers to see, well, this particular response wasn't particularly effective there, so we won't try that, but we can try this one, which has more chance of success. And we incorporate the information from the description and appraisal into a typology, which is a tool for decision support. And I'll talk a bit more about that very briefly in a moment. We've developed a questionnaire. We're focusing on fisheries and aquaculture. We're focused somewhere to begin with. Again, that's kind of most of our expertise. We have got 14 case studies based on this somewhat large questionnaire. We were hoping for more, and we've now reduced the number of questions in order to hopefully get a broader set of responses. So Ian presented some preliminary results from our first attempt at a typology yesterday to Ian Quéré. And he took that reduced set of questions and used a scoring technique in order to put them into a multi-dimensional framework. So using multiple factor analysis, he basically, or rather the results of this analysis show that there are 4 main groupings. We've got 2 groups here of in 4 systems each, and then 2 singletons up here. And then based on the differences between those 2 singletons and the larger groups along those 2 dimensions, basically the first dimension represents the questions related to governability issues, and the second to vulnerability issues. So this begins to allow us to determine what aspects are differentiating these ecosystems and what questions are important. And I am having, sorry. Preliminary conclusions from this work is that, yes, it is possible to create types, and this looks like it might be a useful tool to carry forwards. The typology is really a first entry point to compare crises, to identify solutions, what may have worked where. And it's important to underscore, so the typology, obviously in the scoring system, is a somewhat reduced set of the questions, and it's a simplified approach. Underlying that is a much more detailed database, which is fully described in these case studies. So the idea is that typology directs the user where to go, and then there's a much greater wealth of resource underlying that. One of the things that came out of this is that one of the most common short-term responses, so we asked what the short-term responses were, was more research is required. And that's one of the reasons, or rather, part of the rationale for this tool is to identify case studies where that research has already taken place and that others can learn from that research. So instead of just saying more research is required, the response might be, well, we tried A, B, or C based on this experience over here. So we're still at the very beginnings of this work, as you can see. We want to continue to apply, test, and validate this framework. And in order to do that, we need more case studies, of course. And as I mentioned, we have reformatted the questionnaire, reduced the number of questions, and we're going to relaunch that in the next couple of months. So if anyone is interested in contributing case studies, I certainly invite you to do so. And we're available on the web, or you can contact any one of us directly. Oh yeah, and I'm giving up a chair and Lucy's that. Because, you know, we're an interdisciplinary team, we're natural and social scientists working together. But I suppose I shouldn't self-evaluate. All right, I'm going to skip over this one brief, but just to say that not just a tool for decision makers, but by collecting all this information together, it's also a research tool to detect emerging patterns and learn from what's happening. And imagine this tool in a workshop situation with stakeholders, natural and social scientists together. It could really help people, scientists, decision makers, stakeholders communicate. All right, my last few slides are where next for IMBeR, so I am wrapping up. Writ large in the global environmental change programs, there is a lack of focus on marine systems, and we can make the case that IMBeR can help address this gap. I would argue that all global environmental change programs require a systems thinking approach, but all aspects don't necessarily need that kind of interdisciplinary, transdisciplinary research. So for example, if you're up here working on atmospheric circulation, I mean, this is related eventually through to governance over here. But the scientists working on atmospheric circulation don't necessarily need to be working side by side with the social scientists working on governance issues. But it is critical to place that work in this overall systems context and understand where they link. So what we need to do in IMBeR, I think, is to determine where our comfort niche or zone is within this broad spectrum of sort of disciplinary, interdisciplinary, transdisciplinary approaches. And there's a whole field out there. There are many different options. And I think to start to sort of hone in on to what extent we feel we're comfortable to go forward with those sort of natural social science interactions. I would make the argument that the regional programs of IMBeR are a strength of the program and could perhaps be the main focus for advancing on this field. I mean, essentially, they encompass a socio-ecological system concept. They're very large programs, and perhaps to make it more relevant at the human scale, we need to downsize and to focus on some specific problems. And Colleen mentioned this in her talk yesterday, that we need focused questions, and then then you can have something to direct your science towards, and then hopefully to address. We need cooperative research projects and arenas for discussion. It could be virtual arenas, but certainly physical arenas too. Someone mentioned yesterday, asked a question about working with stakeholders, and that's obviously one of the aspects that could be a part of this research. There are also lots of tools, and as I mentioned earlier, we've talked about some in this conference already. End-to-end models are an obvious example. There's other things that we heard about yesterday, so network analysis, scenario analysis, etc. There's a lot going on that we can benefit from and utilize, some of which has already been done in IMBeR, and much of which has also been done elsewhere. But IMBeR can't do everything. There are limits to what IMBeR can do, of course. It's one global program. And the question is, when do we need to pass the baton? And it's important to remember that we're not alone in this. There are, under just the Future Earth umbrella, there are several other projects which are specifically focused on human dimensions, and in fact have a leading expertise in that area. And I would argue that one of the things that we should be discussing is what can IMBeR feasibly do at a research level, and where should we forge in partnerships with some of these organisations, and how do we do that? And not just within Future Earth, there are lots of other human dimensions related organisations, and they're doing great research. It's fun. And we should be, again, reaching out to those. So I started off with this grasping hands concept in a somewhat negative way, sort of reaching. Now here I want to close with a much more positive message, is that we should be embracing the natural and social sciences together, but we should also be embracing that IMBeR should be embracing these other organisations too, and with that we can perhaps make more progress in the direction of the human dimensions and bring that as a core part of what we do within IMBeR. And so with that, I thank the many people who contributed to this talk, from Clear Talk, ESSAS, ICE and Cyber, and in particular the IMBeR Human Dimension Working Group, who have been the founders of many of the ideas represented in this. Thank you.
Since you put too big to ignore on the slide, I'll give a couple of minutes for people to ask any questions before we move to the next speaker.
Great talk. Question for you, and I missed the first 5 minutes, so maybe you said it and I missed it. No, I apologize for that. But in the end, I think it would have been a nice thing to remind us again. As we think about the ocean also as an area of development, and there's a possibility of a sustainable development goal formulated for ocean and coast. And clearly, our role as the scientific community would be to identify targets and indicators, which certainly must be the tiramisu version of it, right? That must be combining targets and indicators that allow humans and the natural system to be better stewards of coast. And I wonder whether that also is something that could be added to your list in an area of engagement of the science, be the scientific arm, shall we say, of that endeavor to identify what the targets and indicators should be towards a more sustainable ocean as we develop our human and natural system in that one.
Yeah, I mean, I would certainly agree with you. I didn't mention that explicitly, perhaps because under one of my other hats within the industries group, we were very much invested in some of these ideas of how to develop indicators for marine ecosystems. Under that little list I had of end-to-end models, etc., absolutely that's where it would fit, and it could be involved in an area that we more clearly about. And I would like to emphasise the point I'm glad to raise that within the sort of sustainable development goals now, that again, the sort of marine world is quite scantily, and there needs to be a more developed sense of what the indicators should be, and or a better articulated sense, more that kind of area. So, thank you.
Any other? Okay, so we would continue with the conversation, of course. So thank you very much, Alida, for challenging us. I think we're going to be looking forward to a lot of tiramisu as we have our coffee break. I'd like to introduce our next speaker. This is Corinne. She's a professor of climate change science and policy at the University of East Anglia and the director of Timber Center for Climate Change Research in the United Kingdom. Corinne conducts research on interactions between climate change and the carbon cycle. She's the author of the third, the fourth, and the fifth assessments of the Intergovernmental Panel on Climate Change and of the Millennium Ecosystem Assessment. She also co-chairs the Global Carbon Project, a non-governmental organization that fosters international research on the carbon cycle and publishes annual updates on global emissions and scenes of carbon gas. Oh, that's great. So I'll let you talk to us about the California. Thank you.
Thank you. Is that working fine?
any better? Good. Thank you very much for the opportunity to speak today. Let me start by saying that some periods in history are more exciting than others, and I think that we are actually in one of them, possibly the most exciting period in history. You can see it here, 3,000 years of world population. We are today approaching the beginning of the end of this biggest transition, perhaps the only population transition that will take place, at least of that scale. This population transition, at least according to population dynamics people, is going to end probably sometime in the next decade. Raise your hand if you're doing a PhD right now. So you lucky people have probably about 80% chance of seeing this transition. If you are under 50 years old, I would say 50-50% chance. If you're above 50, then, you know, it just goes down from there. And sorry, my daughter said I should not wear my glasses when I give a talk, but actually I need them to read my text. In the process of this transition will end sometime soon, and when that happens, a new balance will need to be established. It will need to be established between society and between the environmental resources that sustain it and allows it to thrive with time. And in the process of establishing that new balance, so at the end of the transition here, some known elements will have to be managed. Most important is to safeguard a resilient space so that the society can continue to thrive. And this picture here comes from the IPCC Working Group 2. The green space is the resilient space. And we need this green space so that we can sustain food and water security, but also peace and stability for society. And the resilient space is threatened by two types of stressors. One comes from outside, is the biophysical stressors that includes climate change, but it also includes pollution and the balance and availability of nutrients. And there's also social stressor, which come from the inside out, that's the yellow bit here, and that includes wealth, increasing wealth. It includes development, but it also simply includes ignorance and inattention. So using the resources, wasting resources. At the base of the resilient space is information about how the world operates and functions, and this is what we provide here in this community and at large. And the Global Change Program have provided heaps of evidence to understand this. For instance, the International Human Dimensions Program, IHDP, has helped a lot understand the social stressors. Diversitas really focuses primarily on the resilient space, ecosystem services, and how do we sustain these functions. The World Climate Research Program on climate, obviously, and the IGBP, International Geosphere Biosphere Program, perhaps I would say at the interface between the biophysical stressors and the geosphere. Each program has grown over the past few decades, particularly the last decade, particularly since 2000 around when we had the ESSP. It has grown to become more interdisciplinary and to occupy more of that space, so much so that now all the programs are a little bit, not quite everywhere, but expanded sideways. Also, what we have done in the research community is that since the 1980s, we have done extraordinary efforts to clarify the evidence on climate change. This is me here, 4 in the morning. I have worked hard. You can see Christopher in the background as well. The day before, we submitted the IPCC Working Group 1 report last September. Over the course of many decades, the evidence has become clearer and clearer. We have worked hard to do one thing, which is to identify and highlight the consensus about climate change, which in the science community, as you know, consensus is very difficult. In the 1990s, we are certain that emissions from human activities will enhance the greenhouse gas effect. 1995, the balance of evidence suggests a discernible human influence on climate change. 2001, most of the warming observed over the last 50 years is attributable to human activity. 2007, warming of the climate system is unequivocal. And 2013, 2,000 pages of evidence, 2,000, working group one alone, incredible success, Peace Prize, and everything. Immense achievement, and I actually mean it, really immense achievement. And as I said, we work really hard, but has it actually worked? Now, with the Global Carbon Project, since year 2007, we publish every year the balance of carbon, so updates of CO2 emissions and their partitioning among the atmosphere, the land and ocean, and many people in this room actually contribute to this. Thank you very much. But what we actually see in the reality in the world outside of science is that year on year, the course of the emissions, which you see there, the black lines, continues unabated. The atmospheric CO2 concentration at Mauna Loa last year went through the roof, broke the 400 ppm level without the blink of an inclination. In spite of the 2,000 pages of evidence of climate science, and in spite of the grandiose effort of our community to clarify all the evidence, so it seems that at present, what we are heading towards is even more steeper emissions following the most fossil fuel intensive and the highest projection of emission scenario. And so it seems that the world that we're moving towards is a world with very low resilience space and where the social and biophysical stressors are face to face, and we are sitting there being very impuissant and watch. One of the issues that we have in science, I think, is that we work under the information deficit principle. Our whole environment, what we research, how we publish, in peer-reviewed papers, journals that are not accessible outside of academia, they're not readable outside of academia, and actually some are not even readable inside of academia, but that's another problem. How we're rewarded, how we are promoted is all based on the production of knowledge. It's the production of knowledge with the implicit understanding for those of us, and possibly most of us, who actually want our research to serve society, that policymakers, the ones who hold the knowledge and the power to decide, that they will base their decision on rational principle of the best available evidence. And this is what we actually operate on in our community. And thus, what we have to do in this framework is continue to produce better and more evidence and to reduce the uncertainty. And once things are really, really clear, so this is the information deficit principles, then the policymakers will act. This is what we operate on. But the reality is not this. And you can read this paper here, actually, that happens to be published yesterday, just beautiful timing with my talk, Nature Climate Change. But the reality is very different. The reality is that policymakers have a lot of different priorities, competing priorities. And the evidence of an issue such as climate change, but many others, is that information and evidence, by and large, is not enough in itself to result into action. That evidence has also to intersect with a number of priorities, with economic interest, with what is feasible within an election cycle, with the values of the community in which you operate, and all of these actions and evidence that policymakers and society have to deal with. And unless we can understand those constraints and learn to frame our science within the limits and inside the societal context, we are going to sit there and watch that transition here take place. Of course, I don't know really how to do things differently. I don't know really what is the way forward and how to assist in a transition, which I would very much hope happens and looks a bit more like this. One where the resilience space is large, one where the stressors are there, but they're very much under control, recognized, and managed in a way that leaves the most resilient space for society to thrive.
beautiful transition to sustainability, many more Nobel Prizes, and so on. I do know one thing though is that we are going to have to conduct our research a little bit differently. And I'm sad to say that this means for us that we are going to have to step a little bit outside of our comfort zone. And everybody in this room, without exception, we need to do one thing that is so simple that we actually don't think about it, and that is we are going to need to talk to people outside of academia. Every one of us, Eileen Hofmann, Sergio Valina, Jim Orr, you have to get out of your comfort zone and go and talk to people outside of academia. Those who raised your hand initially, you have to do this. Oh yeah, and we need to do this because we need to listen to what their concerns are. We need to understand how people think, what makes them operate, frame our messages around their problem, provide solutions to their problem, and these solutions can turn out to also be good for sustainability of the planet by accident, but they're their solutions. We have to understand these issues. So I would like to propose, or even actually I would like to ask, that we all in this room do one thing, and that is to modify, not transform, but just modify the way that we do science so that we integrate in our research discussions outside of academia. And this can be discussions with policymakers, it can be discussions with the public, it can be discussions with businesses, it can be discussions with school children, whatever you feel comfortable with, but it has to be outside of academia and outside of your comfort zone. And I think that this is so important. This is the one critical thing that we have to change in the way we do research, that I'm going to put a number on this. And I'm going to dare to say that you need to spend 20% of your time, 1 day per week, 2.5 months per year doing this. And that writing an IPCC report does not count. What counts is taking the message of the IPCC report to the policymakers, going to speak to the policymakers at the moment you write the report so that you understand their concerns and you integrate it in the science. And with that, 1 day a week, from tens of thousands of scientists around the world, we are going to infiltrate society. This is what we're trying to do. We are going to build credibility, provide solutions, and expand our influence. And with doing this, then the one thing that is really important for us to building this resilient space through time, I think we have more chances. There is no guarantee, but I think we have more chances. And as it turns out, I'm not the only one who thinks about this. And I think, at least this is my interpretation, exactly what the Future Earth program is trying to do, is to integrate science. Because the way I speak now is only because I've been impregnated by discussions with social scientists. Social scientists, they say one thing, they say talk to people. That's what they tell me all the time. Did you ask? Did you ask if that's really what you want, what they want to know? That's what they say. So scientific integration is for your own benefit as well as the benefit of your project, because you can eat the tiramisu. You don't just have to look at it. Co-production of knowledge, that's what it means. It means you go and talk to people, the people you want to talk with, solution-oriented, because in the belief that actually providing solutions moves society forward, whereas problems paralyzes decision-making. So Future Earth is an international research coordination. It's a research platform. By the end of 2015, it will replace the programs that we know. It will build on these. So these will sort of morph into Future Earth. So Diversitas, IGBP, and IHDP are all working to build this tool, to build this platform. Future Earth doesn't actually exist without these programs. Without you guys, it's not going to be anything. It's not the program of somebody else who will tell you what to think. It's your program, and you're going to make it work the way that you want to have it. And eventually, within a few years, WCRP will also morph into Future Earth. At least that's the plan. And what it's going to look like is a bit of a simpler form. It has a scientific committee. I happen to be part of this, but it also has an engagement committee with the same number of members, at least that's coming for the permanent committee, that is trying to make this interface between science and the stakeholder of science at the global level. But actually, it doesn't work if you have a global committee that does global engagement. It's not going to lead to anything. You have to do the global engagement, and it has secretariat. Because it's trying to do science differently, the problems also look different. They don't look like problems like we're looking at carbon climate feedbacks, for instance. The questions themselves are focused on big questions that serve society, such as feeding 9 billion people within planetary boundaries. Mind you, it's the same problem. It requires the same scientific evidence, but the problem is framed towards society because of this interface and this interactions with society that is necessary, reducing disaster interaction, valuing and protecting nature's services, and etc. Now, I get asked about funding all the time. It's not a funding mantra, Future Earth. So the pyramid looks like this. The 10 million at the top is for the coordination, the secretariat, the activities, supporting IMBeR, and that kind of thing. There is a green space here that is opening, actually, because as these priorities get set up, there is also a commitment from funding bodies to link internationally, provide a little bit of funding to have projects at the international level, which is a new tool for funding, but it's still not heaps of money. It's tens of millions. In international terms, it's not so big. Where the real money is really in bringing on board all these national funding bodies who actually are interested in aligning their own research to those of the international community to bring more funding into the system. And finally, the basic disciplinary research, which is there supporting the whole thing. So, as I said, Future Earth is a program in the making. And at the moment, there is a lot of thinking and discussions and interactions with projects about the visioning and priorities. So 3 things are in the making. One is the 2025 success factors for Future Earth. You can say the long-term vision. And that's to be delivered at the end of this year. One is the medium-term research priority that was requested by the Belmont Forum, who is an international funding coordination body, and it wants to have priorities, so this is in the making. IMBeR was part of the discussion and the consultation on this. And one is short-term initiatives, which there was a call for that, and this should be starting very, very soon. I want to give now 3 examples of the kind of priorities that are in the medium term. So these are things that have kind of a time scale of a 3 to 5 year. And I want to give these examples. Now, don't jump on them because this is just a draft document. There are many, many examples, and I've simplified them so I could actually read them here. But I want to give these examples to give you a flavor of the kind of framing that the research question is moving towards in this Future Earth context and program. For instance, understand the biophysical and socio-economic forces that co-produce ecosystem goods and services from local to regional scales. Now, you can see biophysical and socio-economic is linking the natural and the social science, and local to regional scale is trying to bring the message home. The second one, understand how the Earth, its ecosystem and society, again, all the interdisciplinary science have responded to environmental change in the past. That includes archaeology and all the sociological changes to provide perspectives of current and future change for decision makers. So you have to take this project and bring it all the way to decision makers and not just stop at the moment of the evidence. And the last one, develop surveillance, monitoring, observational systems that link climate, health, and economic impact, blah, 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 to support monitoring for the sustainable development goals. So there is an actual purpose to the science, which is to bring it all the way to support the sustainable development goals. This is brilliant. Now, my perspective, just very briefly, I come from an angle, so I'm not pretending to actually say everything that has to be done in IMBeR, but from what I see about the carbon-climate interactions, there are 3 things that in the next 10 years we need to absolutely do. And I showed this graph before. So these, the red four dark red scenarios are the scenarios that have been used by the IPCC to project climate change. The only one that stays below 2 degrees with a likely chance is the bottom one. It's called RCP 2.6. Very nice, elegant name. It stays, its mean temperature is 1.6 degrees. The one at the top goes, the mean temperature is 4.3 degrees, so above 4 degrees. As you can see, we're now following the top. One thing that the IPCC has done, which I think is very, very nice, in my view, this is the best element of the last IPCC just published, is to associate with these emission scenarios the total amount of carbon, cumulative carbon emissions that you can emit. So we have a quota of carbon. If we emit in the future 250 gigatons of carbon, we're following this scenario here. And note in passing that this 250 is less than half what we have emitted so far. If we emit 3 times as much as we have emitted so far, then we go to the top scenario. And it so happens that this relationship between temperature and cumulative emission is linear. The relationship is linear because of 2 things. One is, as more CO2 goes into the atmosphere, the change in temperature decreases. So there's a saturation of the radiation band to greenhouse gases. But at the same time, and this is a big but for this community, at the same time, as CO2 increases in the atmosphere, the sinks weaken, and the carbon, a larger fraction of the carbon stays in the atmosphere. The airborne fraction grows. And these 2 effects compensate each other to give a linear relationship between cumulative emissions and temperature. Now, as we're moving in this direction here, governments around the planet, almost 200 of them, have pledged to keep warming below 2 degrees. They have a problem. They have a big problem. And they are going to try to pass this problem on to us. They are going to challenge us. They are going to say, why on earth is this 250 gigatons? We must prepare our community to defend the carbon balance. Everybody who actually mentions carbon when you talk about your work in the first 2 minutes, you have to know where this number comes from. You have to be able to explain where it comes from. You have to be able to say how your research feeds into this number. Do you believe it? How large is the uncertainty? And is the uncertainty in this number as large that we cannot actually trust this relationship at all, or is it not? And it's not. You can see that the uncertainty, well, you can't see here. Read the IPCC report. You will see that the uncertainty is much smaller around the number than it is around the scenario. So that is Gilberto, Anna, Claire, Matthew, Rick, Dick, KK, Ida, Stephanie, Martin, Laurent. I know that you mentioned carbon in the first 2 minutes when you talk about your work. You have to be able to explain this number. The second one is, as we're moving in this scenario, the second reaction that is going to take place is this actually bad? Is this a bad scenario, or is it actually 4 degrees of warming, something that we can adapt to? So we must develop adaptive solutions because some level of warming we will have, but we also must highlight the risks and limits of these adaptive solutions. We must provide numbers that go beyond an IMBeR diagram, but actually says what is the difference between a 2-degree warming, a 3-degree warming, and a 4-degree warming, particularly if you work on pH, which has additional effects to climate change that are related, but not directly caused by the climate itself. And that is Geraint, Maike, Eugene, Eileen, Ulf, Patricia, Jean-Pierre, and many others that I don't know your name. You have to be able to provide quantitative numbers to actually identify the pathways that we can safely take or manage, and the pathways where we actually really don't want to go. And the final one is bringing information to the local, regional, and national levels where decision makers where decisions are made, and that is to work with your local environment, your local environment agency, and decision makers to actually, as I said before, understand their problems. So in effect, when you compare IMBeR with Future Earth, it's a lot of framing. It's a lot of reframing of science. It's a lot to do with the focus and direction, not the inward thinking about what we like science is because we love science and I love science too, but to be a bit more outside thinking, how are we perceived from the outside and can we actually make our science go a little bit farther? And in terms of framing new directions, I think that these requires understanding the decision-making context and the information needs and providing solutions. Building responsive frameworks is very useful, frameworks that stays with time, like the Ocean Health Index, the climate modeling intercomparison project that informs IPCC is solid, it stays with time, carbon budget. These are useful activities that could be expanded and actually be made to progress a bit further and bring the human dimensions at the heart of IMBeR's strong science basis. Thank you.
Well, let's begin.
Thank you very much, Corinne. Corinne is the Director of the Sahara Foundation. Corinne, very passionate speech, excellent. A comment and then a question. Comment is, you use the word generated knowledge a lot. Actually, what most of us do most of the time actually is provide information and not knowledge. And there is, I think, a fundamental philosophical difference between those two. I think what you're trying to tell us by going out and speaking to the public and so on and so forth actually is that interface between information and knowledge. So that's just a discussion point. The question is your model of competing pressures of biophysical pressures and social pressures working in and out is a very good model, I think. One of the things that you showed, however, was whilst there was a change in the balance between the biophysical and social pressures, was the size of your circle did not change. Now, there are many, I think, in the community who say, actually, one of the ways that we're going to be able to accommodate these competing pressures actually is to grow the size of that circle. And there are many, I think, in the economics community who say, actually, we don't have a problem. Yes, we recognize those two competing pressures, but the way out of it and the way to increase the size of the green resilience bit actually is to grow the size of the circle. I wonder if you have got a comment on that.
Thank you, Nick. I haven't thought about it actually, so I'm taking a little bit off guard here. It's not my schematic. I would have thought that the world is limited. I mean, we have limited resources. So if you grow the size of the circle, implicitly, doesn't it mean that you become more efficient at using the limited resources that we have? Possibly. Possibly. Yeah, I mean, this is an illustrative circle, really. What I'm trying to say with this illustration is that what we're trying to do is to safeguard a resilient space, whether we do it by becoming more efficient or whether we do it by reducing the stresses. We have several options, but keeping the resilient space is really quite important. And at the moment, we are providing a lot of information, but there are elements that work. I don't want to say nothing works. Deforestation, for instance, is going under control at the moment. But by and large, a lot of the big global change issues, we provide more and more information, and the effect is really not representative of the amount and quality of information. How we do this, yes, there's a lot to say about that.
Thank you for the talk. I just want to make a comment about our responsibility. I think we agree with you most of the examples that we have to communicate more to science and to be careful and to put time on that. But how many of us, when we are in a panel to choose a candidate, then evaluate and think and make evaluate this type of work. Usually, the only issue they come to the young people, they are applying for businesses, they do not have index, impact, blah, 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 blah. And the other things, they don't count nothing. And we're in this time. So we have some of the responsibility to try to change a little bit and to this kind of action. Of course, it's more difficult to be objective in this because we don't have
thank you for your comment. I completely agree with you that there are changes to be made at the institutional level as well. So the impact of your work, the time you spend outside of academia is to some extent at the expense, not necessarily though, because if you have a better understanding of the issues, you also produce better paper, at least you can. But the way that people are hired and promoted is one of the big issues that we have in terms of expanding the reach of science, because we're promoted based on the number of citations and the number of paper and so on. Things are changing though, they're changing around the world. In the UK, for instance, we have these impact assessment of institute, and it's done every 7 years and it comes with real money. So if your institute can demonstrate impact, you have more money for research. This is, I think many institutions are moving in that direction, but institutions have to move as well. I completely agree with you.
Okay, I know there's about 2 or 3 hands up. If you can just, I know we are a little bit off in time, but let's just take care of these 3 questions. I have one over there, then from here, and then one. Yes?
Just a point to the University of Bergen. Thank you very much. Very, very nice talk. And but I have one issue which came up to me when reading the science plan or the strategy of Future Earth. And what I would like to ensure in future that one thing exists in this program as well is, I think the strengths of programs such as IMBeR or SOLAS and many of these other big projects was that it's really a bottom-up process happening in these projects. So people thinking about, for example, ocean acidification, promoting it, doing research, discussing controversially, and coming up with new ideas that nobody has thought about some time ago. So one thing is to do solution-oriented research, but I think we have to ensure also that we don't find pseudo-solutions. So it must be highest quality. And I would like to encourage Future Earth and all the big programs to really keep on this dimension of the program as well, to keep the grassroots approach and to give it space to find the best solutions possible.
Thank you, Christoph. I think in the past we were a little bit too science-oriented, and maybe Future Earth is trying to push in the other direction, and indeed the balance, it's a fine balance between the two that has to be reached. I see perfectly your point.
Thanks, Corinne. Nice talk. You mentioned the need to communicate outside academia, and you mentioned Oceanography. We did that, and we produced a fact sheet, for example. You also mentioned the IPCC. I think IPCC could do much better communicating its findings. You know, even the summary for policymakers is a very complicated document to pass on to the public. And I think maybe a fact sheet of 1 or 2 pages, you know, from the IPCC on each of the 2 reports would be a tremendous thing that then could be used by us. How many of us have read the summary for policymakers from page 1 to the last page? I don't think many of us have done it because it's already quite a big document.
Yeah, yes, that's right. The IPCC sees its role as communicating directly to policymakers and not outside of policymakers. And there's a lot of issues to this because this summary for policymakers is broadcasted widely, but it's unreadable. So yes, absolutely. There is a consultation led by WCRP at the moment on the IPCC process. Actually, I'll send you the link if you want to make some suggestions. That would be very welcome.
Well, thank you so much for your inspiring talk. One of your key messages was to talk to the people outside academia, and I would like to mention that Ratana showed the other day a video that features local fishermen in South India. It is a piece of art. It's not a piece of science. It's a piece of art, and it shows how local fishermen in South India suffer from climate change. You might show it again. Thank you.
Thank you for that.
All right. So thank you again for the wonderful talk. Let's join me please in the a lot to think about throughout the conference. And I'd like to invite Eileen to take us to the next stage. This is an exciting time for all of us here. We have been looking forward to this, I think. Thank you, Eileen.
Thank you. Thank you. I want to thank Alida and Corinne for providing very stimulating and informative presentation, and very appropriate to the next activity here, which is our breakout groups. And I'm going to just briefly go through this because it's more important. Yeah, we've seen it several times already at this meeting. These are the current IMBeR science themes. And yesterday, we talked about the themes that had come out of the information that had been provided by the community. And I'll just put these up one more time, is that this is the continued integration of biogeochemistry ecosystem research, the impacts of climate change and climate variability, multiple drivers, stressors, and responses of society, the integration of marine biodiversity and conservation, and what we just heard a lot about today is the integration of the ocean-human system. As I said yesterday, these are not independent themes. There is an enormous amount of overlap between them, but these are simply put here as a way to begin our conversations about defining the research agenda for IMBeR for the next 10 years. I'm going to just put this up. These are the themes again, and the point I want to make here is that we have breakout leaders, and the room numbers here for theme 1, Alistair Hobday, Donna Tollin, and Gerhard Herndl have agreed to lead that group, and for those interested, I ask you to go with them. Global change and climate variability, again, the challenge that came out of this. Laurent Bach, Nikki Gruber, and Anders Auschwitz have agreed to be the breakout leader for this, and this is again in the DA. 3, KK Wu, Keith Criddle, and Jean-Pierre Gattuso, looking at multiple drivers, stressors, and human responses. Marine biodiversity and conservation, Dan Costa, Claudio Campagna, and Tatiana Manierson, and looking at marine biodiversity and conservation. The human ocean system, Alida, Ratana, and Olivia Mine have agreed to do that. The breakout 6 on data management, and the challenge, as we talked about yesterday, is to expand data and metadata. And Alberto Fiola, Cindy Chandler, and Susan Liu have agreed to do that. And they are involved with the IMBeR data management working group. And then capacity building of human networks, which is a very important part of everything we just heard today, and how we move into the future. Jim Zhang, Julie Hall, Ed Urban, and Susan Goodman. All right, so having said all that, what do we want the breakout groups to do? All right, so the discussions this morning are an hour and a half or so, which I realize is not a lot of time, but hopefully it will be sufficient to at least come up with some thoughts about whether or not what we're asking is that, is this theme or topic appropriate as we move forward? What's missing? What is needed to implement the theme or the topic? How well does that theme or topic align with the international and national research agendas? We just heard from Corinne all about Future Earth, what it's looking at. How well do these match what Future Earth is wanting to do, as well as looking at what
our other co-sponsor for the Scientific Committee Oceanic Research is interested in having us do in the future. So what would be of interest to them? And then do these themes or topics together address the key questions related to marine ecosystems and global change? If not, then what does? So don't feel constrained by these. If they're not right, they're not appropriate, suggest something else. All right, so we're going to have a report this afternoon and the plenary presentations from each of the breakout groups. So the breakout leaders should appoint rapporteurs and then decide who's going to provide the report back to everyone here. Please keep these reports at 10 minutes or less. We're only looking for maybe PowerPoint 1 or 2 slides, or an oral report is fine, because we don't want to miss the conference minutes tonight. Okay. All right, and then we're going to use this feedback from everyone to revise this position paper and to help us develop and guide us in developing the research plan for the next 10 years. Okay. Again, to remind everybody, we've set up an online system where you can go in and input your information if you don't have the opportunity to do it today, or you're on the plane going home or next week, you think of something, please provide it. We have this mechanism to do it, and so just submit your information. And the position paper, as I said, will be discussed and revised following this meeting. We'll put it out for the community to comment upon, and then we're going to use that to develop the next phase of member research. All right, so again, thank you for your input, and we're scheduled for a coffee break now, and then the breakout groups will begin at 10:45. Thank you very much.